Hi, welcome to ISE503, and this lecture is on Structured Query Language Part 1. So we are starting a new topic which is SQL, Structured Query Language, and this is the first lecture on this topic. And the lecture slides are taken from our textbook which is Principles of Database Management. So what will we learn in this topic? We will learn about the role of SQL in relational DBMS or in relational database management system and SQL's role in RDBMS. We will learn about the two important class of SQL, the data definition language, which is also called a DDL, and then we will get into the DML, which is data manipulation language, and these we will learn in SQL. So towards the end, we will learn about the views, how can we define views in SQL, and finally we'll spend some time on SQL indexes. So let's look at the key characteristics of SQL. So in fact, SQL is the lingua franca of relational DBMS, RDBMS. It is one of the most popular language that is used as DSD, DDL, as data definition language, and as DML. So we will first look at the versions. So the first version of SQL is SQL 86 that came in 1986, and the most recent version is still the one that was provided in 2016, which is called SQL 2016. Now let's look at the standards of SQL. It is accepted by ANSI in 1986. So ANSI stands for American National Standard Institute, and in 1987 it was also accepted by ISO. ISO means International Organization for Standardization. So you can find so many vendors, vendors of SQL, like Oracle is one, MySQL is another one, and then you have Microsoft versions as well. So yeah, each vendor will provide their own implementation of SQL, and that is the reason why we will sometimes refer to those as SQL dialect. And these vendors, they somehow provide some additional vendor specific specification as well, but mostly you will find the SQL very similar, because all these vendors, they provide the implementation of the core specifications of SQL standard. So you should not expect a lot of variation. Mostly the SQL that you use from say Oracle versus MySQL, and any and Microsoft SQL, they're all going to be mostly similar. Okay, so one thing which is very important about SQL is its nature. It is set oriented and it is declarative. So if you could remember the discussion that we had in the previous chapters, we did look at the set oriented specification, or set oriented DML, and we also learned about record oriented DML. So we understood in that discussion that set oriented language or query language is more efficient because it can operate on sets of records at a time. So the beauty of SQL is that it is set oriented, and here, because it is set oriented, unlike the record oriented query language, we do not need to specify the navigational details for the query. Okay, so it is set oriented as well as declarative. Declarative means you just specify what information we need to return. We don't need to provide the details of how that information should be returned, right? So that's the beauty of declarative SQL. We don't need to provide the procedural details, just the information that we need, and the SQL can do the magic in its background. So yeah, there are these query processors. They will figure it out. They'll come up with the query execution plan and all. Okay. Good. Another additional feature or the advantage of SQL is that it is free form language. Now the free form language means a language where the indentation is not important. So if you think about the language like Python, then Python is not free form language. In Python, indentation is important. Whereas in case of SQL, indentation is not that important, but it is always recommended to follow some kind of indentation to improve the readability of an SQL statement. SQL is case insensitive. Uppercase and lowercase means the same thing. But here again, it is recommended that we follow some conventions where the SQL keyword should be used in uppercase, whereas the other the objects like the tables and their columns should be used in lowercase. So yeah, it is case insensitive, but yes, we should we should use some convention just to make it more readable. Now, SQL can be used either interactively on a command prompt, or SQL can be embedded in a program as well. So that's what we mean over here. We are saying that it can be used interactively from a command prompt, or it can be executed by a program. And this program is often written in high-level programming languages like Java or Python. Okay, and these languages are called the host programming language. Good. So here you're looking at a picture of my SQL workbench, and in this picture, it is this part is important where you will find the window for query, SQL query window, and in this SQL query window, you can write the SQL query. So here we are saying select p.prod_nr, a comma, p.prod name from product p where 1 is less than, and then we have a subquery. Well, here my intention is not to explain to you what is happening in this SQL. We will, in fact, discuss this query in probably the next video, which I'll do on SQL data manipulation language, SQL-DML. But yeah, here the message is to understand that we can write the SQL query here in the SQL window, and this is the snapshot from MySQL workbench. So this query that you have written, you can run this, and after running this query, you have this result over here in the result window. Okay, so that is an example of writing the SQL query on a kind of command prompt interactively. The second picture that you're looking at right now corresponds to the second scenario where the program is written in Java, and here we need to import some APIs. So these relational DBMS, they provide the API, application program interface, so that those can be used in some host programming language like Java. Okay, so that's precisely what is being done here. In the line number 3, we import the API, and then this is the whole Java program. We don't, again, my intention is not to explain each and every statement written over here. I just want to highlight this portion in this program. Okay, and in this portion, query is a string object, right? And in this string object, if you look at, then this is what? This is just a simple SQL query that we want to fire from this program that is written in Java. Okay, so this is the second scenario where we are making use of SQL through a host programming language. It is embedded. The SQL query that we have has been embedded inside a Java program. So yeah, these options are available mostly. Now let's look at another very interesting picture that is providing the role of SQL in three level database architecture. In the beginning of the course, we learned about the importance of three-level database architecture, and we learned that there are these three different models. The external data model, then we have logical data model, and then at the bottom we have internal data model. So here we want to see like how SQL is going to help us out with these three data models. So let's start from the top. We have the concept of views. You can use SQL view to define the external data model. So here in this picture, we have three different views, right? You can think of those as just view 1, view 2, view 3. And the purpose of the view, which helps us in designing the external data model, is to customize the database to different class of database users. Okay, so that's one of the reason why we defined the external data model, which is for customization. There are other advantages as well, like authorization, data protection. Okay, security, I should say security, and the other one is customization. These are the two basic reason why we define external data model. So using the concept of views in SQL, we can define external data model. And then if you come to the next level, which is logical data model, then in logical data model, we use SQL stable definitions. Okay, and in the third model, which is internal data model, using SQL we will have the database definitions. You'll have SQL stable space definitions and SQL's index definition. So this is an important information which I'll request you people to keep in mind while you are starting. How SQL helps us out in different layers of this three-level database architecture. Okay, good. So now what we have to do, we will look at the data definition language part, which we call as DDL in short. We will look at the key concepts of DDL, look at some example of DDL, and then we will look at referential integrity constraint, which is a very important concept. And this is related with relationships. Finally, we will look at the drop and alter command in SQL. So let's start with the key DDL concepts. So the first thing here is the concept of schema, SQL schema, right? So it's an important definition. So we will see what is there in SQL schema. So what is done in SQL schema? We provide the grouping of tables and other database objects such as the views, constraints, and indexes which logically belong together. Okay, so when you're making your database, right, it may make sense to put the database objects which are related with each other at one place. And how can we do that? It will help us in organization. So the best approach would be to define an SQL schema. So let me read that one more time. SQL schema helps us in grouping of the tables and other database objects such as views, constraints, and indices or indexes which logically belong together. Now question arises, how can we do that? So here we go. I feel if I'm right, then probably this is the first SQL statement that we will look at. So here, what are we doing? We will create a schema. How to create a schema? Simply use this keyword create followed by schema. Create and schema are separated by the space, and then using the create schema keyword, you will give a name, right? So this is the schema name. The name of the schema is purchase here. So we want to create a schema named purchase. So that's the reason we said create schema purchase. And after that, you're looking at this keyword, which is authorization. Now, authorization keyword is used to associate or assign an owner of this schema. So here the owner is B Basins, right? So B Basins is the owner of the schema purchase. So B basis will have all the privileges associated with this schema, will have all the it can perform all the operations in other words on this schema, which is purchase. All right, so this could be a schema for our purchase order management database. So one more time, you will use the keyword create space schema, give the name of the schema, which is purchase over here, and then you should associate an owner with this schema, which we have as B basis in our example. Now, well, that was about schema. Let's look at the table also. In the schema, you will have probably multiple tables. So the SQL table, what is a table? That's the first question. So the table in SQL implements the concept of relation from relational data model, right? So the previous chapter was on relational data model. Okay, and there we learned about the mapping of the conceptual data model, which was ER model, to the logical data model, and the logical data model in that previous chapter was relational model. So now, having had a good understanding of what a relational data model is, now we will see how can we implement relational data model using SQL. So in SQL, we have the concept of table, and this table implements a relation from relational model. Good. Now the question arises, okay, fine, we followed that. How to now implement these tables? How to define our tables? For that, I'm marking it as 2 and 3. We will use the same statement, which is create, right? But now we are not creating a schema. In fact, we are creating a table inside the schema. Therefore, in place of schema, we will say create table. In a similar way, you will first write create space table, and now the name of the table, right? This is the name. So here there are few bullets after that, which means this statement is not complete yet. We are focusing on the first line of the statement, right, which is about using the create statement with the table and then the table name. In the statement number 3, you would see another create statement with create table, but 2 and 3 are different. 3 is different in the sense that now we are saying create table product, but we are also specifying the corresponding schema. All right, so when you say create table purchase.product, then here you want to create the table product inside the schema purchase. If you don't specify that, like the way we have done in statement number 2, then in that case, the table product will be created in your current schema or the default schema. Okay, so now here we have some information about the data types. So what will come next? In the next slides, we will learn about the columns in the table. And the columns are fine. The concept of table that we have in SQL maps to the concept of relation in a relational data model. Now in relation, we had the attribute types. Now for attribute types, we have the concept of columns in table. Now in columns, we will have the attribute types, and the attribute types will have different kinds of data type. And the data type is important because the data type will help us out in understanding the kind of data that we can keep in that column, right? And then it's not only about the type of the data, it is about the format of the data and also the range of values that we can store in that column. Okay, so here are some important SQL data types which I would leave as an exercise for you people, but yeah, I'm also marking those important for in exams. These are going to be important. There's not much to explain. That's the reason I'm not spending time reading every row in this table. So that is a reading assignment for you. I will simply read some of these data types. We have char n, that is for string of size n characters. And here the size is fixed. We cannot have variable data fields. So if you say char 10, then yeah, your record will use all the 10 characters if n is 10. Now we have more flexible version, which is varchar, and so these two data types are for string of characters. Then we have a small int, then we have float, then we have double, then integer and small int is for whole numbers. You can look at the range here. Small int is for smaller integer values. Int is for longer integer values. Then we have float, and double is for fractional values. Then we have date time, boolean, and blob. Okay, it is important you should remember these data types. Now here, back to the DDL concept. What are we doing here? Here we are doing something new, more interesting. I will start numbering from the scratch, so that's the reason I put that as 1. So we have already used create a statement in two contexts. In the first context, we used create with the schema. We created a schema using create statement, and then we created a table. So for schema, we said create schema. For table, we said create table. Right now, we want to create a domain, right, which is a very useful feature. We can also define our own domain. So that's what is being done here. We are creating a domain with the keyword create space domain, and we have given a name product type domain, which stands for product type domain. So we are defining a domain for the product type, and that's the reason we have given it a name product type domain. And now we are using a keyword as, because we need to tell what kind of format we are supporting or what kind of domain we are supporting in this domain name, which is product type domain. So yeah, this is going to be varchar 10. That means it's going to be a string with a maximum size of 10 characters. And then we are using a keyword check. So the purpose of the check is to make sure that the condition that we have inside these parentheses is satisfied. All right, that's the purpose of using the keyword check. So fine, along with check, we have these parentheses, and inside the parentheses, we are using the keyword value space in, and then we have another pair of parentheses with these values: white, red, rose, and sparkling. These are all strings. Okay, so the whole purpose of putting this check over here is, right, let me put that in the box. Now the very purpose of putting this check over here in this create domain statement is to make sure that when the user is providing the value for the column that supports this domain, prod type domain, then the only values which are allowed are either white or red or rose or sparkling. Right, so yeah, that's a very useful feature to have, where you can define your own domain type, and then after this domain type has been defined, like the prod type domain, you can use this domain any number of time you want, maybe in multiple tables. Okay, and later on, if you find that probably we need to add an additional value over here, then yeah, you need to only modify your domain, which is going to be very efficient. Okay, yeah, very convenient to do that. Fine, now let's look at some more interesting things associated with columns. Now, what are columns? Columns are the attribute types of the relational data model. Now we will see how can we define the columns for a table, but before that, let's learn about some constraints or some rules that we want to specify on the columns. For some columns, we may want to specify these constraints. For others, we may not. So let's look at some important constraints. So we have this keyword primary key. So using primary key keyword primary space key, it is a constraint which defines the primary key of a table. How? We will see that with the help of the example. Guys, this is very important. Then for foreign key also, we have a keyword foreign key that is used as a constraint in SQL to define a foreign key of a table. We have another keyword unique, which is a constraint that defines an alternative key of the table. This is important. I hope you remember the definition of alternative key. We learned about candidate keys. Now, candidate keys are the attributes or the set of attributes which can be used in a table as a primary key, right? Or which can be used to uniquely identify the tuples of a table. Now, if we have the candidate keys, say more than one, then one of the candidate key we can pick as the primary key. Now, the remaining candidate keys which were not picked as primary key are called the alternative key of the table. Now, to declare an attribute or the set of attributes as the alternative key, you need to use the keyword unique. Now, we can also, let's look at the not null constraint. The not null constraint can be used on column, which will prohibit the value of null for that column. Okay, you will see in the example where we have used the not null constraint. Then we have a default constraint. Default constraint sets a default value for a column. This is very useful. Then we have the check constraint that you already saw in the previous slide when I was explaining to you the create statement that we use to define a constraint. In that constraint, we did use the check constraint. Now, the purpose of check constraint is that it defines a constraint on the column values. So in the previous example, we were constraining the product type to be some strings only. We will be using this ER diagram to understand some DDL statements. Therefore, let's spend some time to recap what we had in this ER diagram. I'm pretty sure that we have seen something similar to this in our conceptual modeling chapter. So this is an ER diagram which is for the purchase order management system, and there are three entity types: supplier entity type, the product entity type, and purchase order entity type. Supplier entity type has the attribute types which are sub and R, which is supplier number, then sub city, sub status, sub name, sub address. So these are all the attribute types of the supplier. Sub stands for supplier. And out of these attributes, the supplier number, which is sub and R, is our primary key. Then for product, we have the attribute types prod and R, which is the product number, that's the primary key of product entity type. Then we have the attribute type prod name, prod type, available quantity. For purchase order, we have we have two attribute types, PO and R, which is for purchase order and R, that's the primary key, and PO date, which is for purchase order date. Now let's look at the relationships. The first relationship that I would like to discuss is supplies, which is defined between, I think I should call it relationship type. So the supplies relationship type is defined between the supplier entity type and the product entity type. Let's look at the cardinalities. A supplier can supply minimum of 0 to a maximum of n products, and a product can be supplied by minimum of 0 supplier to maximum of m supplier. Okay, and this supplies relationship type that we have here has two attribute types, the purchase price and the delivery period. So if a product is being supplied by a supplier, then for that product the supplier must have the purchase price and also the delivery period. Okay, now let's look at the second relationship type, which is on order. Right, so this on order relationship type is defined between the entity type supplier and the entity type purchase order. Now one supplier can have 0 minimum to and maximum purchase orders, whereas for one purchase order there should be one and only one supplier. So in that way, the purchase order entity type is existence dependent on supplier entity type. Okay, good. Now finally, we will look at this relationship type, which is between the purchase order and the product. Now, if there is a purchase order, then for that purchase order, we can have 1 to n purchase order lines. Okay, and for a product, there can be 0 to n purchase orders. All right, and this relationship which we have between purchase order and product is captured in this relationship type, which is PO line, purchase order line. Here in purchase order line relationship type, we have the attribute type, which is quantity. Okay, so this should serve as a revision for you people to recap the concept of the entity types, relationship types, and their cardinalities, and the concept of existence dependence. Good. So here in the next slide, we have the mapping of the ER model to the relational data model. In the relational data model now, we have a relation supplier, and the supplier relation has these attributes, sub-NR, sub-name, sub-address, sub-city, and sub-status, which can be easily mapped from ER diagram. And sub-NR is our primary key for supplier relation. The second relation is product, where we have the attribute product NR, which is the product, which is for product number, and that's the primary key. Then product name, product type, and available quantity. Again, a very simple mapping from the ER model to the relational data model. The third relation that you're looking at is for supplies relationship type, right? And here, well, purchase price and delivery period you can directly take from the ER diagram, but we will have to add the foreign keys here, two foreign keys. The sub NR is the foreign key that is referring to the primary key sub NR from supplier table, and prod NR is another foreign key which is mapping or referring to the prod NR attribute of the product table. These two attribute types taken together will form the primary key. That's the reason these two are underlined. And these fonts are italicized or slanted because they are the foreign keys. Now, the fourth relation that we have here is for purchase order, and purchase order was an entity type. And for purchase order, we have the primary key, which is PONR for purchase order number. And for purchase order, we have PO date, the date for purchase order, and sub NR is the foreign key that is referring to the sub NR from the supplier relation. And in the final relation that we have, which we are calling as PO line, there are these three attributes. PONR is the foreign key, which is referring to PONR from the purchase order relation. PRODNR is the foreign key that will refer to the attribute PRODNR from product. And the quantity is an attribute of this relationship itself. Now PONR, which is purchase order number, and PRODNR, individually these two are foreign keys, but taken together they are forming the primary key of PO line relation. Good. Now, after having this understanding, we will move on to the SQL part. And here goes the first interesting DDL statement, which we have written for the table supplier, right? So how do we create the table supplier? Well, that will say create table supplier, and then look at these outer parentheses. Now these outer parentheses will enclose all the columns that we will have for this table called supplier. Now for each column, let's start with supplier number, SUPNR. SUPNR is char for, that means we are allowing it to be a string of maximum 4 characters long. This is not null. This is a primary key. We don't want it to be null. So here for supplier number or SPNR, there are two constraints, not null and primary key, right? And they are separated by space, not space null, space primary key. Good. So that completes the definition of the first column of this table supplier. Now with the comma, we have the second column definition. which is subname varchar 40. So for supplier name, we are allowing the flexible supplier name maximum 40 characters long, and we don't want it to be null. That's the reason we are saying not null. The third column defines the supplier address, subaddress, similar to the subname. It is varchar 50 characters, maximum 50 characters. Then we have the definition of, or the declaration of, the next column, which is subcity. It is again varchar 40 characters long. Finally, we have substatus. Substatus is a small int, right? And that completes the definition of the create statement for our very first table, which is supplier. Next, we will look at the second table, and this is important because you may be asked in the exam to write the create statements to create a table corresponding to either an ER diagram entity type or a relation from relational data model. In the next create statement, or the next TDL statement, we are creating the table product. Therefore, we'll say create table product. And yeah, these two outer parentheses are important. Then goes the first column, which is prod nr. Prod nr is a string of maximum character 6. So we say prod nr char 6 or char 6. Not null, primary key. Excuse me. Prod name varchar 60, not null. And now we are providing some constraints in the table definition. Okay, so that starts with the keyword constraint. We'll say constraint UC1. We are calling it a UC1. You can give a name to the constraint. And this is useful if you are giving some name to the constraint, and later on you can drop that constraint. Okay, so we say constraint UC1 unique prod name. This is interesting here. So what is prod name? Prod name is this column. All right. So in fact, this second line is also associated with our second column only. Prod name. We are saying that prod name is varchar 60, not null. That's one constraint on this. And there's another constraint which we are specifying as uniqueness constraint, right? Which will make the prod name as what? The alternative key. Right, we define the alternative key using the keyword unique over here, right? And inside the parentheses you will give the name of the column that you want to make as the alternative key. Then we have the next column, which is prod type. It's varchar 10. And then look at another constraint that we have, which we are putting on prod type, right? So this constraint is applicable to prod type, where we are saying constraint comma constraint CC1 check prod type in white, red, rose, sparkling. Okay, so it's similar to the way we defined the domain earlier. Now the final column over here is available quantity, which is integer. Okay, so these two create statements were very interesting, and please make sure that you follow each and every line of these create statements. Now let's look at the third interesting create statement for the table supplies. The third create statement, which is for supplies table. Create table supplies. Here you have the first column, that is sub nr char 4 not null. Then we have prod nr char 6 not null. Purchase price double 62. Now the double data type is used for fractional values, and in double you see two numbers inside the parenthesis, 8 and 2. 8 means that we will have in total 8 digits in this number, in the data for this column, and 2 after the comma means that these many digits will have after the decimal. Okay, and here you can put the comment as well. So the comment is been put using the keyword comment. It simply says that the purchase price that we have here is in euros, EUR. Okay, that's the currency over here for price. After that, we have the next column, which is delivery period. Its its unit is time, or its data type is time. And here we have a comment which says that delivery period is in days. Finally, we will have the primary key, and primary key is the combination of supplier number and product number, right? These two attributes, supplier number and product number. Good, right? Let's see if we have anything left here. Yes, we do have something very important coming up. So this table that we have created supplies, it is for the relationship type. Relationship type. Okay, and these two columns that we have, supplier number and product number, they are in fact the foreign keys, right? So up till now we did not say anything about foreign key. We did define the primary key, but we didn't say anything about foreign key. So what follows is the information about the foreign key. So please pay attention to what you are about to see. Fine. So we'll say that for foreign key sub NR, which means that the sub NR at column that we have is in fact a foreign key. Similar to the way we did for primary key, we will say foreign key, and inside the parenthesis you will put the name of the column, which is S sub NR. And then this sub NR that you have as a column here, it references, right? So the foreign key references a primary key of a different table. So the same information we are putting in SQL like this. Foreign key sub NR inside the parenthesis references supplier table, and in the supplier table the column which is supplier NR itself. Good, fine. That's not complete. We also want to add some more information here for this foreign key supply number, saying that on delete cascade, on update cascade, right? So this is something extremely interesting and slightly tricky to understand, and that explanation will come in the later slides. Okay, and specifying on delete cascade, on update cascade refers to the referential integrity actions, right? So we will learn about that, but for the time being, just remember that this is how you declare a column as a foreign key. Use the keyword foreign key inside the parenthesis, put the name of the column which is your foreign key here, and this should be followed by the keyword references to connect this foreign key to the corresponding primary key in a different table. That's what we are doing by saying references supplier, and inside the parenthesis we specify the very column which is being referred by this primary key. Okay, sub NR, that's the primary key of supplier table. Similar kind of thing we will have to do for prod NR also. So we'll say foreign key prod NR references product prod NR inside the parenthesis, and on delete cascade and on update cascade. Okay, good. We have one more table which is purchase order. I think there should be one more after this, but let's focus on purchase order for the time being. You'll say create table purchase order. PONR for purchase order number is char 7, not null, primary key, right? Similar to the way we had defined the primary key in other two tables, which were supplier and product. Same kind of thing we are doing for purchase order as well. Then we have PO date, that is of PO date type, followed by a sub NR, which is character 4, not null. And this sub NR that you have is the foreign key. That's the reason we say it's foreign key sub NR references supplier sub NR, right? And on delete cascade, on update cascade. The final table, I think this is the final table that we have, is PO line, purchase order line. So we'll say create table PO line. PONR is char 7, not null. Prod NR char 6, not null. Quantity integer. Primary key is the combination of these two. So you'll say primary key inside the parenthesis PONR, PRODNR. Then yeah, you need to connect the foreign keys. You'll say foreign key PONR references purchase order PONR. Okay, and on delete cascade, on update cascade. For the other foreign key, which is prod NR, you'll say foreign key prod NR, references product prod NR, on delete cascade, on update cascade. Okay, please try these things yourself. First, try to understand these things, and once you understood, try to write these, create statements yourself, and then match your answer with what we have over here. Now, the most important thing is referential integrity constraint. What is it? Okay, so it relates with the foreign key thing. So it says that a foreign key has the same domain as the primary key it refers to, and either uh, it occurs as a value or it is null, right? So that is very important statement. So what we are trying to say over here is that if we have a foreign key column in a table, say the supplies table, right? The supplies table is a table for relationship type between the product and supplier entity type, between the product and supplier tables, right? Then here we have two foreign keys in the supplies table. One is sub NR, which is referencing to the sub NR in the supplier table. Now the values that you have in the foreign key, which is the sub NR column in the supplies, that value should be present in the corresponding table supplier, or it should be null, right? So that's what we have over here. The foreign key has the same domain. First of all, their domain should be same. If in a supplier table we define the sub NR as the char 7 or char 6, I don't remember what it was, then yeah, the same domain should be used in the supplies table also. It should also be char 6 if it is defined as char 6 in supplier. So the domain, they should have the same domain type. Foreign key has the same domain as the primary key it refers to, and either its value occurs as the value in the original table, in the referring table, or it is null, right? So that's very, very important. Now question arises, fine, we understood this rule, but what happens if the foreign keys, what happens to the foreign keys when the primary key is updated or deleted, right? So let's assume that in supplier, there is a supplier with in the supplier table, there is a supplier with supplier number 37, and that the supplier number got changed, right? We want to change that for some reason to 40. Now what will happen? Because those tuples which we're referring to 37 now, for them we need to do something, right? So that's what we have here. What happens to the foreign key when the primary key is updated or deleted? That 37 could be changed to 40, or the supplier with number 37 is removed. Then what will happen to the tuples in the table, say supplies, which is referring to the supplier with supplier number 37? Okay, so that's the issue we need to look into. What happens to the foreign key when the primary key is updated or deleted? So there are some options here which are very, very important. So on update or delete cascade update, right? Or remove on update delete cascade, that means the update or removal should be cascaded to all the referring tuples. I will use an example to explain this thing to you. So that's one option. On update and delete, on update or delete cascade means update or removal should be cascaded to all the referring tuples. On update delete restrict means update or removal is halted if the referencing tuples exist. On update delete set null, what does it mean? It means that the foreign key in the referring tables are set to null. On update delete set default means the foreign keys in the referring tables are set to their default values. Good. Let me use an example to explain these things to you. Here, supplier is the referenced table. Reference table is the table whose primary key, like supplier number, is used as a foreign key in other table. So reference table is supplier, And the supplies and purchase order, these are the referencing table. Referencing table, we have two referencing table, supplies and purchase order. So in supplies we have sub NR, that is the foreign key, right? And this foreign key is being mapped to the supply number, or referring to supply number of the supplier table. Similarly, in the purchase order also we have this sub NR as the foreign key, and this one is also referencing to this sub NR of the supplier table. Good. Now let's use this example of the supplier with the supplier number 37. And yeah, so for supplier 37 we have the corresponding tuples from supplies. So for these 1, 2, 3, 4 tuples from supplies, if you look at their supplier number, then it's the same, 37. That means these 4 tuples in supplies are referring to the supplier tuple, whose name is at Fundum, address is 82 or Wacker Drive, Chicago 95. In purchase order also, all the 5 tuples, 1, 2, 3, 4, 5 tuples that we have, they are all referring to the same tuple, right, of the supplier named ad fundum. Okay, now we need to discuss all the options that we saw in the previous slide. So let's start with the first thing, right, where we want to update this 37 to 40. Okay, so this value we want to update to 40. So what are the options available? With the update, with the cascade option, right, let's look at the first one. On update cascade, what does it mean? On update cascade simply means that if you change the value of 37 to 40 by update, then all these values that you have in the referencing tuple, their value should also change to 40. That's the cascading impact, right? Update all the referencing tuple supplier value, foreign key value to this updated value. So if supplier number is changed to 40 in the supplier table, then all the referencing table that are referencing to the supplier with supplier number 37, their supplier number value should change to 40. Cascading impact. Now let's discuss the same thing on delete. If this thing is deleted, right, in place of update, let's think about deletion with cascade. If I delete this supplier with supplier number 37, then in cascading what will happen, all these referencing tuples in supplies as well as in purchase order, they should be deleted, right? So that is the cascading impact of deleting. Delete all the referencing table which are referencing to the tuple that got deleted. Okay, so that's the cascading impact. Well, let me erase this thing just to remove some clutter so that we could discuss the other options available. We just saw the cascading thing, right? Cascading concept has been discussed. We need to look into the restrict. The next should be the restrict option. So in the restrict option, what is done? If we want to update or change, update or delete this your supplier with the supplier number 37, then with restriction, this update or the deletion of this tuple would be restricted because there are these tuples from the other table, like 4 tuples over here from supplies and 5 tuples from purchase order that are referencing this tuple. So as long as we have the referencing tuple for a specific tuple in the supplier table, then yeah, we cannot update or delete those. That's the restrict option. Okay. And the third option is the set null. Yeah, set null. Set null simply means that what we will do, we will delete this tuple, but after deletion we'll put all these values at null, right? So all these supply numbers as null. So that's the option of setting the null. Foreign key values are set to null if the corresponding tuple gets deleted from the reference table. And the last option is setting to default, which simply means that if we had defined some default value for the supplier number in the foreign key, then yeah, let's put that default value when the corresponding tuple from the reference table gets deleted. Alright, so this is a very interesting example which will help you out in understanding these four options. And the four options that I mentioned, that we just discussed, for referential integrity actions are extremely important. You should understand their meaning and the difference. Now let's look at the drop and alter command. So the drop command can be used to drop or remove database objects. So the drop can also be used with cascade and restrict. So let's look at some example of drop. You can drop a schema. So here we are saying drop a schema, purchase cascade. Now let's first understand this part and then I'll add cascade later. So drop is extremely simple. You can remove or drop remove a database object, and here our database object is the schema named purchase. So that schema you can drop or remove by simply saying drop schema purchase. If you want to remove a table, you will say drop table with whatever table name. Okay, drop table drop table product. You can remove a product table by that command. So drop schema purchase will simply remove the purchase schema. But if you add the cascade in this statement, then what will happen? This cascade will, trigger a cascading effect where all the referencing objects, which are all the referencing database objects, which are referencing the purchase schema, will also be removed. So that's the cascading thing. Okay. Now, in place of cascading, you can use restrict. In the restrict case, what will happen? If there are some database objects which are referencing this schema purchase, then in that case, this drop schema would be denied, right? It will not work. This will only work if it is cascade, right? If you say restrict, then yes, if we have some objects which are referencing this purchase schema, then yeah, you cannot, because we are using restrict. Let's try the same thing on table. You can drop a table by saying drop table, product, and cascade. Cascading will have the same impact as the cascade will have on a schema. All the tables which are referring to the product will be removed as well. You can specify restrict by saying drop table product restrict, where the removal operation or the drop operation of product would be halted because there are other tables that are other tables or other objects which are referring to this table product. Let's look at another interesting command, which is alter. Alter statement can be used to modify table column definitions. So how? Let's look at some examples. You can alter a table. Let's look at the first case. You will say alter table product. And how are you altering it? You're adding one more column. So you can change the table definition by adding more columns in there. You can say alter table product add prod image. So in that way, you are adding a new column which is called prod image, and its data type is blob. Blob stands for binary large objects. Okay. You can also use the alter table in this way, where we are saying alter table supplier, alter supply status, right? Sub status is a column which is already there in supplier table. We want to change that, or we want to alter that column definition. So for that, we will say alter table supplier, alter sub status, set default to 10. Okay, so this is a new property that we are adding to the supply status, putting a default value of 10. Okay, so that was it. I will stop right here, And yeah, thank you so much. Take care. Bye bye. I'll see you in the next class or the next lecture. Bye.